Anti-personnel mines are a form of mine designed for use against humans, as opposed to anti-tank mines, which are designed for use against vehicles. Anti-personnel mines may be classified into blast mines or fragmentation mines. The latter may or may not be a bounding mine. The mines are often designed to injure, not kill, their victims in order to increase the logistical support required by enemy forces that encounter them. Some types of anti-personnel mines can also damage the tracks on armored vehicles or the tires of wheeled vehicles. The international campaign to ban landmines has sought to ban mines, culminating in the 1997 Ottawa Treaty. Although this treaty has not yet been accepted by a number of countries including the United States, Israel, Russia, the People's Republic of China, Pakistan and India, anti-personnel mines are used in a similar manner to anti-tank mines. In static mine fields, along national borders or in defense of strategic positions as described in greater detail in the landmine article. What makes them different from most anti-tank mines, however, is their smaller size, which enables large numbers to be simultaneously deployed over a large area. This process can be done manually, via dispensers on land vehicles, or from helicopters or aircraft. Alternatively, they can be dispensed by cargo-carrying artillery shells. Other uses specific to anti-personnel mines are where they are deployed on an ad hoc basis in the following situations. Typically, anti-personnel blast mines are triggered when the victim steps on them. Their primary purpose is to blow the victim's foot or leg off, disabling them, injuring, rather than killing. The victim is viewed as preferable in order to increase the logistical burden on the opposing force. When a person steps on a blast mine and activates it, the mine's main charge detonates, creating a blast shock wave consisting of hot gases traveling at extremely high velocity. The shock wave sends a huge compressive force upwards, ejecting the mine casing and any soil covering the mine along with it. When the blast wave hits the surface, it quickly transfers the force into the subject's footwear and foot. This results in a massive compression force being applied. In most cases, the victim's foot is blown off by the blast wave. The resulting injuries to a human body depend on the size of the mine's main charge, the depth, type of soil it was laid in and how the victim contacted it, e.g. stepping on the mine, using all or part of the foot. Different types of soil will result in different amounts of energy being transferred upward into the subject's foot. With saturated clay-like soil transferring the most larger main charges result in a release of significantly more energy, driving the blast wave further up a target's foot and leg and causing greater injury. In some cases even described as severe as traumatic amputation of the leg up to the knee. Secondary injuries from a blast mine are often caused by the material that has been torn loose by the mine's explosion. This consists of the soil and stones that were on top of the mine, parts of the victim's footwear and the small bones in the victim's foot. This debris creates wounds typical of similar secondary blast effects or fragmentation. Special footwear, including combat boots or so-called blast boots, is only moderately protective against the destructive effects of blast mines, and the loss of a foot is a typical outcome. Blast mines have little effect on armored vehicles, but can damage a wheeled vehicle if it runs directly over the mine. Small blast mines will severely damage a tire, rendering it irreparable, while some types could also damage adjacent running gear. The mine casing houses the components of the mine and protects it from its environment. Early mines, such as the ones used in the World War II era, had casings made of steel or aluminium. However, by the middle of the conflict, the British Army was using the first practical, portable metal detector, the Polish mine detector. The Germans responded with mines that had a wooden or glass casing to make detection harder. Wooden mines had been used by the Soviets in 1939. Before the appearance of metal detectors, in order to save steel, some, like the PPMD mine, continued to be used into the 1980s as they were easy to make and hard to detect. Wood has the disadvantage of rotting and splitting, rendering the mine non-functional after a comparatively short time in the ground. Mines manufactured after the 1950s generally use plastic casings to hinder detection by electronic mine detectors. Some, referred to as minimum metal mines, are constructed with as little metal as possible, often around 1 gram, to make them difficult to detect. Mines containing absolutely no metal have been produced, but are uncommon. By its nature, a mine without any metal components in it cannot be found using a metal detector. The fuse mechanism is designed to set